Right, so in this session we're going to move to more challenging probability questions now. We're going to be looking at combining different events, so different outcomes, different probabilities. So this is more as sort of moving into the grade C and the grade B area. Okay, before we do that, I just want to make you think again about what happens when you add or multiply decimal numbers that are between 0 and 1, because as we've been talking in the previous lessons, any numerical value for probability is on a scale between 0 for impossible and 1 for certain, and whether you're in a decimal, a fraction or a percentage, that is the case. Now when you add probabilities, what that means is you're going to end up with a larger value. So for example, if you have got a probability of 0.3 and a probability of 0.2, but if you add 0.3 and 0.2 together, you get 0.5. Well, 0.5 is a bigger number than either of the numbers that you started with. So in terms of probability, that probability is a greater chance than either of the ones that you started with. And that would be the same if you were working in fractions as well. Remember, you can't add fractions unless the denominators, the numbers on the bottom, are the same. So they're both out of 7. So if I've got 2 sevenths and 3 sevenths, the sum of that is 5 sevenths. Well, 5 out of 7 is a bigger value than either of the ones that you started with. So if your probabilities are measured as fractions, the same will happen, that your initial probabilities, when you add them, give you a bigger value. But because we're talking about values between 0 and 1, you should never end up with a result or a combined probability which is greater than 1. If you do, you've gone wrong. So when you're adding probabilities, you're increasing the likelihood of something happening. When we come to multiplying numbers between 0 and 1, the opposite happens. So if we're multiplying 0.3 by 0.2, hopefully you remember from work you would have done in previous years on multiplying decimals, you multiply the digits that you've got there, so you get 6, and then you count the number of numbers that are after the decimal point. There are 2 digits after the decimal point, so there will be 2 digits after the decimal point in your outcome. So when you multiply 0.3 by 0.2, you end up with 0.06. Well, 0.06 is a much smaller number than either of the ones that you start with. So when you're multiplying probabilities together, you end up with a smaller chance of something happening. So as I've said in the bullet point, if you multiply them together, you will end up with a smaller value and hence a decreased likelihood of something happening. And the same goes with the fractions. When you do multiply fractions, you do multiply the numerators, the top values together, 6, and you do multiply the denominators, the bottom values together, 7 sevens, 49. Well, 6 out of 49 is a much smaller fraction than either of the ones that you started with. So in the same way as you have up there, when you multiply the probabilities, you end up with something that's much more unlikely to happen than when you add the probabilities. Okay, so adding increases the chance, multiplying decreases the chance. So when we work through this and you're looking for a handle, if things get a bit confusing, that's what you need to go back to. Adding increases the chances, multiplying decreases the chances. Now in the GCSE intermediate tier, you need to be familiar with different types of events, and you have one set of events which are called mutually exclusive. Okay, in the syllabus, that's language that we need to talk to you about, but don't worry too much about it as far as how you would deal with an exam question. But let's talk through this. So a mutually exclusive set of events are ones where they can't happen at the same time. Okay, so for example, getting a head and a tail when a coin is flipped once. Well, that can't happen. If you're flipping a coin once, it's either going to land on a head or it's going to land on a tail. It can't do both at the same time. So those outcomes are mutually exclusive. If one happens, the other can't. Similarly, turning right and left at the end of the road. If you get to the end of a street, you can do one or the other. If you turn left, you can't also turn right. So those would be mutually exclusive events. And what you find when you're talking about mutually exclusive events is you using the word or. You can have head or a tail when you flip a coin. You can turn left or turn right. So if you find you're using the word or, then it's likely you've got a set of events that are mutually exclusive. So that's what I've said there in blue. When we combine events using the word or, the probability increases. So if you go back to what we're talking about there, up here, for an increased likelihood, you add the probabilities. So the word or means that you add the probabilities together. So in maths terms, if we have two mutually exclusive events, A and B, so mutually exclusive, if one happens, the other can't, then the probability of A or B occurring, and this is how we write it, so P is a signal that we're talking about probability. Probability of A or B happening is the probability of A plus the probability of B. And here's a fairly straightforward example of what that actually means as a maths question. So if a jar contains 1 red, 3 green, 2 blue and 4 yellow marbles, the probability of picking a yellow or a green marble at random from the jar would be. Okay, now you could do this just straight away from the information that you've got, but if I just lay this out in a way to explain it. So the probability of me getting a red marble out of the jar would be 1, because there's only one of them, out of 4, 6, 10, because there are 10 marbles in the jar. The probability of me getting a green would be 3 out of 10. The probability of me getting a blue would be 2 out of 10. And the probability of me getting a yellow would be 4 out of 10. They want to know the probability of picking a yellow or, there's the trigger word, green. So P yellow, P yellow or green would be the probability of yellow, which is 4 out of 10, plus the probability of green, which is 3 out of 10. Or means add the probabilities. The denominator is the same, so the answer is going to be out of 10, and you add the numerators, the numbers on top. So the chances of you getting a yellow or a green marble is more than you getting a red, a yellow on its own or a green on its own, because you've increased the chances. Now, you would have been able to answer that question just with a basic level of probability, because you've got all the information you need. You would add the yellow and green together at the start, so I've got 3 and 4, I got 7 chances out of the 10. So if you're using the word or, you add the probabilities. It's really, really important you fix that in your mind, because next lesson when we come to you looking at probability trees, that's really, really important. So or means add. Then we come to independent events, which is the other term that we need to be comfortable with at intermediate tier. So two events are independent of each other when the probability of one event occurring does not affect the probability of the other occurring. When talking about independent events, we find ourselves using the word and. So and is the trigger for this. For example, if we consider the outcomes of rolling a die, so a single dice, and flipping a coin, it doesn't matter what outcome you get on the head. For example, it doesn't mean that if you get a head, you can only get even numbers on the dice, or if you get a tail, you can only get prime numbers on the dice, or whatever. The outcome of flipping the coin has no effect on the outcome of rolling the die. So the outcome from flipping the coin does not affect what happens on the die. So the outcome from flipping the coin does not affect what happens on the die. Similarly, if you roll a 3 on the die, it doesn't mean, well, that means you're going to get a head, or that means you're going to get a tail. They're completely independent of each other. And when we combine events using the word and, the probability decreases. It's less likely that this and that will happen as opposed to this or that. So, if the probability decreases, going back to that little preamble that we did at the start, a decreased likelihood comes from a multiplication of the probabilities. So for two events A and B, the probability of A and B occurring is probability of A multiplied by the probability of B. And this is where students get a little bit confused, because up until now the word and in maths pretty much means add. What's 3 and 4? 7. What's 4 and 5? 9. So in arithmetic, and means add, but in probability, and means multiply. Because if something, two events happening together, it's less likely, so the probability decreases. If I give you a context for that, hopefully it'll help make it clear. So imagine that Greenhill, we're going to take a netball and a rugby team to play against teams from Haverfordwest High. Can we say that the results are independent? Well, do we think that if the netball team win, that will influence the result of the rugby team, the rugby result? It shouldn't. It shouldn't have any effect. So we should be able to say that they are independent events. So will the two results be independent? Yes, because the result of netball will not affect the outcome of the rugby match. Okay, or similarly, the result from the rugby match won't affect the result of the netball match. Now you could sort of argue here and say, oh yeah, but it depends. You know, if the netball game happened first and they won, then the rugby team would find out and it would make them feel a bit more confident. If there was no other influences, both matches started at the same time, then they would be independent events. When considering the results of the two matches, which would be the most likely outcome? Both of our teams winning, or one of our teams winning? Well, I hope you would understand or recognise there that it's more likely to come away with one win. I'm not even considering a loss. It would be more likely, if you were to put money on it, you would think, well, it's going to be safer for me to say, well, either one of the teams will win rather than both. both of them winning would be more unlikely, and that's because they're independent events. So to summarize, the likelihood of either team winning is greater than the likelihood of both teams winning. In probability language, P, netball win or rugby win, is greater than, that probability is bigger than the probability of netball winning and the rugby winning. And then this is the only bit you need to remember really, is that if you find you're using the word or, then we add to increase the probability. If we find ourselves using the word and, we multiply because we're going to end up with a smaller probability. In that example, we were oring. The chances of you getting yellow or green would be greater than you getting yellow and green. So for example, find the probability that a coin will land on heads 3 times in a row. So with a coin, the probability that it's going to land on heads once would be a half. The only other thing that could happen is it lands on tails. The probability of it landing on tails is a half. So what's going to happen here is I'm going to flip the coin once. Then I'm going to flip it a second time, and I'm going to flip it a third time. So what I'm looking for here is the probability of a head and a head and a head. So the first flip is a head, and the second flip is a head, and the third flip is a head. I'm using the word and, so I multiply. So it's the probability of a head and multiply probability of a head and multiply probability of a head. So the probability of getting a head is a half times a half times a half, which is 1 times 1 times 1 is 1, 2 twos are 4, 4 twos are 8. So the chances of me flipping a coin 3 times and each time getting a head would be 1 out of 8, 1/8, which is smaller than a half. So you've reduced the chances of that happening. So the key to this work is this bit. If you're oring, you add. If you're anding, you multiply. Okay, so we got some past paper questions then for you to have a go at. Okay, some of them are really straightforward and you don't really need the maths behind the anding and the oring. A couple of them then you do. The answers are on the bottom of the back page for you to check that you're getting them right. And I'll post my worked solutions and a video clip of that afterwards as well. So see how you get on with those.